Hey all, it's Mooch. Welcome to Minding Your Mechs episode 24. Today we have the Keen mechanical mod in brass, a collaboration between Timesvape and Stan, TenaciousTXVapes. We have the normal setup, drawing 30 amps through this electronic load from a 3.5 volt power supply. We're going to read the voltage drop from across the atomizer, through the mech, through a solid aluminum slug that passes the current back up and out. We'll read the total voltage drop here. Then I crunch the numbers, and in the table I link to in the description section below, I subtract the effect of the atomizer and the slug, and you're left just with the power loss in each of the mechs I test. So you can just go down and directly compare the different mechs and the performance and their power loss. Let's get started. I'm going to check for 0 volts here. That is 0. To prevent any arcing damage from accumulating and affecting the voltage drop, what I do is I press the contact and then I fire a 2-second pulse of 30 amp current. We can read the voltage. And then when current stops, I let go of the contact. That way I'm never pressing or releasing the contact when current is flowing, so I can't get any arcing. And later on in this video, we'll do a separate test where I do 200 button presses with a battery, and we check for the arcing damage then. And going to 0 volts and firing. 76, 75, 50, that was further over to one edge, 44, 47, 45, moving around a little bit, 55, back to center, 62, 65 or so, and a little bit of variation is normal. 42, 50, 55 or so, 60, we'll do just dead center, 70, 55, I'm going to call it 60.060. And what we're going to do now is I'm going to switch to the 18650 adapter and 18650, because that shouldn't make a difference, but I want to double check it anyway. None of the adapters I've tested so far, that's made any difference, because this piece of metal it's incredibly thin, micro ohms of resistance, which means maybe 1,000th of a volt voltage drop going through it, so it shouldn't make a difference as long as it's reasonably flat. If I can remember how to screw something in. Make sure it goes to 0. Okay, and firing. 43, 65, 45, 75, again I'm moving my thumb a little bit, 45, 55, it's still a little hard for me to pick one here, 60, 45, that's in the edge, 60, it's like 55 to 70. I'm going to call it the same 60. It varies anywhere from 45 to about 70 millivolts, which is good. It's all going to depend where you're putting your finger on the button. And also will depend, I think, on how far you've got this moved in or out, so how much pressure you're putting on the battery and the different size of your battery, etc. But it's not a big difference. The difference between 45 millivolts and 70 millivolts is very small in terms of power loss. So it's certainly not anything I'm concerned about. And let me get set up for the arcing testing. Using a Samsung 30T battery. And what I'm going to do is I'm going to fire this 200 times. You're not going to have to watch. that, I'll jump forward. This is a 0.1 ohm load, and then we're going to take a close look at the contacts and see what arcing damage there is, if any. There's got to be some, I think, but we'll check. And 1, 2, 3, 96, 197, 198, 199, 200. Oh yeah, that's toasty. And the way this works, I remove the spring. You've got the button pushes that ball contact up, and that goes into the ball recess underneath here. So we're going to take a look at these two, and while I'm looking at it with a magnifier, I'll put up a macro photograph. So we'll take a look at this one first. And I don't see, I barely see anything. That's incredible. It's if someone told me there was no arcing damage, I'd believe them. Just the tiniest bit of pressure spots. And now we'll look at this ball contact. Oh, just a couple of the tiniest. That's wonderful to see. That is a nicely designed content. I don't know if it's just because it's getting, if the shape is what's doing it, or if it's just all of this is just touching all of that inside, and so it's just leading to, the current is spread around, so it doesn't arc. But I really just don't see anything. It just, I wouldn't even be bothered with doing an alcohol wipe or anything after 200 presses. So maintenance on this would be wonderfully low, at least in terms of arcing damage and taking care of that. Certainly in brass and stuff, you want to clean the threads, keep those oxidation free. These threads, those internal threads, this point, etc. That was wonderful to see. Okay, let's do the thermal testing and find out, for the heating that does occur, does it happen in the 510 threads, in the threads up here? Actually, it's not going to be up here. Sorry, that's just the beauty ring. So it's in the 510 threads, the threads here, or whether it's in the button itself, which you'll be able to see down through the bottom. Okay, I've got it wrapped in a single layer of black electrical tape because metal is a very poor, especially polished metal, very poor emitter of infrared radiation. On the end, I've got a rubber bumper, self-adhesive, and a little piece. You can see it's kind of got squared off corners of black electrical tape up against the button, so we'll be able to at least see a ring of what the actual temperature is around the bumper. I'm going to pass 30 amps through this. The temperatures you see in the lower left and upper left-hand corner are the minimum and maximum that the camera sees in its field of view. That will not be the temperature of the mech while you use it. This 30 amps is being passed through it just to find out where the heating is, not to tell us what the temperature of the mech will reach. And let's start passing 30 amps through it right now. And I ran the numbers. The 60 millivolt drop is about 1.4 watts total. Okay, we're seeing a little bit of heating down here in the button, and that is 1/2 the voltage drop, or the power loss, excuse me, that the Dreamer had, that Stan also developed, TenaciousTXVapes. So that's fantastic to see that performance improvement. The best performing brass mechs were about 0.2, 0.3, excuse me, about 0.5, 0.6 watts. So this has about 2 to 3 times the power loss, but it's only about 1 watt more at a 105 watt vape. I just don't think you're going to see the difference. And I'll shut up about that. And I can see the power loss is down here in the button, and you can see the button itself around the nub. You can see it now. That's the hottest temperature is 30°C. It looks white hot. It's barely above my skin temperature. But the heating is coming from the inside, probably directly at the contact itself, and it's making it to the outside of the button assembly here. That's the seam, and then it takes a little bit extra time to cross the seam. Nothing is over here on the right, up on the top. It's all down here and on the bottom. Let's go a little bit further, and I'll rant some more about actually what 0.9 watt difference between this higher power loss in the Keen versus the broadside Admiral in brass. I just don't think you're going to see that at 105 watts. I wouldn't if someone handed me a 104 watt vape and a 105 watt vape. Okay, just rotating to look for hot spots, and I don't see any. Amazingly, right here, you can see it shifting back and forth, even through the black electrical tape. There's some reflection coming through. All right, let's look at the end again. All right, 32C, the bright ring, the copper button. So any of the power loss is down here where the contact is, which is expected, but it's nice to not see it anywhere else. And it's just a hint. Well, actually, no, that's reflection coming through the tape. I may actually need 2 layers for something like this of electrical tape. So that is the thermal imaging for the Keen. I was really curious when arcing damage might eventually be visible, so I did another 200 clicks using a 0.1 ohm load and a Samsung 30T, and you can see in the photo of the ball contact above, you can finally start to see some of the arcing dots, but they're really minor. So I think there's just multiple points of contact every time I press the button, and also as I press the button in different places, the contact points also shift. You can see in the cup above, there are multiple contact points also, but none of them show any kind of big damage even after 4 clicks with a 0.1 ohm load. So I'm impressed. You can check the table in the description below for a comparison between the different mechs that I've tested and the power losses. That's all for today. Thank you for watching.